You know, there are these secrets hiding all around us, in plain sight, ancient blueprints written into the very fabric of our world, just waiting for someone to decode them. Today, we're diving into one of nature's greatest and, you might say, most impossible engineering marvels. Just look at this giant sequoia. It's a skyscraper built by nature. Now think about this. To get water to the top of a man-made skyscraper, we need massive, high-energy pumps. It's a brute force operation. And yet, this tree moves hundreds of gallons of water to its leaves every single day, silently, with absolutely zero electricity. How on earth is that even possible? And right here is where it gets really strange. Human engineering, our best solution, uses brute force. We pump, we create high pressure, we push fluid through pipes. But if you were to cut into the trunk of a sequoia, water doesn't spray out. There's no pressure. It's a system that seems to completely defy the laws of physics as we understand them. Okay, so to understand this, we need to look closer, way closer, deep inside the trunk, at a hidden superhighway that makes this whole thing possible. This highway is called the xylem. Now, what is it? Well, it's a vast network of dead, hollow tissue that forms a system of microscopic straws. And these straws run from the deepest roots all the way up to the highest leaves. Seems simple enough, right? So, is that the big secret? Is a 300-foot redwood just a giant, really complicated straw? Well, if you think that's the full story, you are in for a serious surprise. Here's what most people don't realize. Physics puts a hard, non-negotiable limit on the straw effect. You can only pull water up about 33 feet using suction before the column of water literally breaks apart under its own weight. A sequoia is nearly 10 times that height. So that simple straw theory, it's completely impossible. The mystery just got a whole lot deeper. So if the tree isn't sucking water up from the bottom, what in the world is going on? The answer is absolutely brilliant. Turns out the engine isn't at the base, pushing. No, it's hundreds of feet up, at the very top, and it's pulling. The power source was hiding in plain sight the entire time. And here's how it all works, in what scientists call the cohesion tension theory. First, sunlight hits a leaf, causing water to evaporate from tiny pores called stomata. But second, and this is the key, water molecules are incredibly cohesive. They're sticky, they cling together like tiny magnets. So as one molecule evaporates, it literally pulls the next one up to take its place. This creates a chain reaction, a continuous tension that pulls an unbroken column of water, molecule by molecule, all the way from the roots. This quote really just illustrates the whole concept perfectly. It's not a pump, it's a passive, solar-powered hydraulic lift. It's a silent, elegant system that uses the fundamental properties of water itself to achieve the impossible. But what happens when that rope of water is put under too much stress? Say, during a drought. What happens if it snaps? And this is where things get really interesting. Because of course, nature already thought of that. When the tension becomes too great, that water column can snap, forming an air bubble. This is called cavitation. Now, in a man-made pump, this is catastrophic. It can literally destroy the machinery. For a tree, you'd think it would be a death sentence, blocking the flow of that life-giving water. And this physical stress is terrifyingly real. Using highly sensitive audio equipment, scientists can actually hear a tree screaming in ultrasonic frequencies as these tiny bubbles form and pop under the immense strain of a drought. That is the literal sound of the system breaking down. But here's the thing, the tree is designed for this. Its xylem conduits are all connected by these tiny check valves. When a bubble forms, these valves instantly seal off the damaged pipe, isolating the blockage. The tree then simply reroutes the water flow through millions of other neighboring conduits. It's an unbelievably elegant, built-in fail-safe system. So, cohesion tension, it's an incredible theory. But how do we know it's true? Well, because it's not just a theory, it's a design principle that's literally built into the tree's anatomy. And this detail, this changes everything. Scientists have discovered that a tree's internal plumbing is precisely structured. Those xylem conduits, they're narrowest at the top of the tree and get progressively wider toward the base. Now, any engineer will tell you this is the perfect design to minimize hydraulic resistance over a long distance. It's exactly how you would design an efficient piping system if you were starting from scratch. And the proof is right here in the numbers. This table shows a value called the scaling exponent.
Now, theory predicts that for a tree to maintain perfect hydraulic efficiency as it gets taller, this number needs to be at least 0.20. Okay, so now look at the data for the world's tallest trees: the sequoia, the giant sequoia, the eucalyptus. They don't just meet the threshold, they blow right past it. They are mathematically optimized for their staggering height. It's perfect design.
And what's even more incredible is that the tree actively maintains this perfect design as it grows. With each new annual ring, the conduits at the base are made wider, dynamically adapting the entire system to its increasing height. It's a living blueprint, constantly optimizing itself for peak performance over centuries.
And really, that's the bottom line here. Our engineering is based on applying external force, brute strength. Nature's engineering is based on elegantly harnessing the internal properties of the materials themselves. It's a fundamentally different and, in so many ways, a superior philosophy of design. No moving parts, no electricity, just a silent, solar-powered system that can last for millennia.
Which leaves us with a final, kinda awe-inspiring thought. If a living organism perfected this technology thousands of years ago, what other incredible solutions are just waiting out there in nature's blueprints, ready for us to discover? What other impossible problems has life already solved?
Thanks for watching. Support BioVellum by liking, subscribing, and sharing. Let's explore the secrets of nature together.